All right, geometry. We are in lesson 14. Yesterday we talked about rotations. Today we're talking about reflections. So first of all, let's think back to lesson 12, where some of you worked on this exercise in class and you were asked to describe to your partner how to reflect a figure across a line. The greatest challenge in providing the description was using the precise vocabulary necessary for accurate results. Let's explore the language that yields the results we're looking for. So if I look here, I have triangle ABC, right here, ABC is reflected across segment DE and maps onto triangle A prime, B prime, C prime, A, B, C prime. So using your compass and straight edge to construct the perpendicular bisector of each of these segments connecting A to A prime, B to B prime, and C to C prime, what do you notice about these perpendicular bisectors? So, oh goodness. Perpendicular bisector connecting each of the, first we need the segments. So I'm going to connect B and B prime. I'm going to connect C and C prime. Sorry, every once in a while I know my head gets in the camera. And then A and A prime. If I do a perpendicular bisector, of B and B prime, notice it's the line of reflection. If I do a perpendicular bisector of C and C prime, let's see what happens. We'll see again that I have the line of reflection. And you can guarantee that if I did the perpendicular bisector of A to A prime, we would get the line of reflection. So that's what we notice about these perpendicular bisectors. Label the point at which segment AA intersects segment DE, AA and DE, as point 0. That's that point right there. What is true about AO and A prime O? Okay, this segment is equal in measure to that segment because a perpendicular bisector cuts a segment into two equal pieces. Okay? Alright, so you just demonstrated that the line of reflection between a figure and its reflected image is also the perpendicular bisector of the segments connecting corresponding points on the figures. In the exploratory challenge, you were given the pre-image, the image, and the line of reflection. For your next challenge, try finding the line of reflection provided. The line of reflection provided the pre-image and image. Okay, so we need to draw that, but you guys should do awesome at it. So, example 1. Construct the segment that represents the line of reflection for quadrilateral ABCD and its image, A prime, B prime, C prime, D prime. So let's construct the line of reflection. Now, in the previous example, we saw that our line of reflection was the perpendicular bisector of each segment that connected between the pre-image and the image. So let's just construct a few of them. We'll do C and C prime first because it's really short. Sorry about that. It's really short and will be easy to construct. And let's just test it with D and D prime, just because I feel like doing it twice. Okay, handy dandy little compass. Sometimes actually it's harder to do a problem with a short segment with the compass than a long one. Okay, oops, yeah, I already moved it. And then this side. That should be my perpendicular bisector. Let's test it with D and D prime. Yep, there we go. Notice one very important fact about reflections. Every point in the original figure is carried to a corresponding point on the image by the same rule, a reflection across a specific line. This brings us to a critical definition. So reflection. This very wordy statement right here is basically saying that any point for a line L in the plane, so if we have a line L, a reflection across line L is the transformation of the plane by points moving across the plane the same distance and perpendicular to it. Okay, perpendicular, or moving across the perpendicular bisector. We're not too worried about these very precise notations. We're very worried about the definitions of reflection, the definitions of rotation, and then translation, which we will get to. So don't dwell too much on the notations. We'll get to it. What I really want you to understand is how to construct them and really what they mean by reflecting a figure across a line and how to check to see if it's an actual reflection. All right, let's construct the line of reflection across each image that was reflected. So I'm going to construct a segment between the image and the pre-image, and then I'm going to construct the perpendicular bisector. This is why I gave you guys each a compass before you left today. I was thinking. Oh, I moved it. There we go. Oh, I don't want it to be we're gonna make it a segment. Perpendicular bisector here. Okay, we don't have dots, but we can see that it's a reflection. Not quite. There you go. So you have shown that a line of reflection is the perpendicular bisector of segments connecting corresponding points on a figure and its reflected image. You've also constructed a line of reflection between a figure and its reflected image. Now we need to explore methods for constructing the reflected image itself. The first few steps are provided for you in this next stage. This is sort of fun. The task at hand is to construct the reflection of triangle ABC over segment DE. Follow the steps below to get started, then complete the construction on your own. All right, so construct circle A, center A with radius such that the circle crosses DE at 2 points, labeled F and G. Oh, wrong way. So you're going to follow along. So construct that circle. It's done for red. Okay, giving you F and G. Now construct circle F. Center F with radius FA. So center F, radius FA. So your point should go on F and your lead on A. That gives you the circle right here. And circle G, center G with radius A. Radius GA, right there. Label the unlabeled point of intersection between circles F and circle G as point A. Point A. Okay, this is the reflection of vertex A across DE. Let's do that again for vertice B, and then I'm going to make you do C on your own. So I'm going to draw a circle that has to cross line DE at 2 points. Doesn't matter where. Awesome. Now I need to draw 2 more circles. So here we have our 2 points. I'm going to draw 1 circle with the radius up to B. Oops. See, it happens to all of us. And then a circle, same radius at this point. And this gives me point B prime. Okay, you do point C prime, and that should give you, so here we'd have A prime to B prime. C prime is going to be over here somewhere, and you'll get the triangle reflected over a line DE, or segment DE. Things to consider. When you found the line of reflection earlier, you did this by constructing perpendicular bisectors of segments joining 2 corresponding vertices. How does the reflection you constructed above relate to your earlier efforts of finding the line of reflection itself? Why did the construction above work? We used all the circles, and they're all the circles give us our perpendicular bisector. They follow the rules. So we've used circles with given given radiuses to find where they intersect, which would be this segment is what we drew earlier to find our perpendicular bisector. So really we're just finding the distance between B and the line and B prime, or A and your segment and A prime. So the same thing here. We would find about where C is to finish our triangle. Okay, example 5. Now try a slightly more complex figure. Reflect A, B, C, D across E, F. Okay, you can do this. Okay, if you'd like to do it in class tomorrow, that's fine. Let's see, your problem set is, let's check. 4 problems, 5 problems, so plenty of time. All right, good work today.